All right, continuing with 1.6 part 2. This is descriptive statistics, but now instead of summarizing the data with a number, like we did in part 1, we're summarizing with the plot. So in the first of these videos, we saw how to make a histogram on a calculator. In this video, we're going to see how to make what's called a stem and leaf plot. What you'll see is this is a little bit quicker, a little bit easier than your histogram, but frankly, it'll be a little bit less useful. It's one of those things you kind of want to see, but see it in passing. Expect it to show up now and again, but not a whole lot in this class. So the idea with the stem and a leaf plot is to make a stem and leaf plot, you need some data. So I'm going to go ahead and reuse this data that I used in the histogram example. And the logic is the last digit in every observation will be what's called your leaf. So in this observation right here, the 9 is the leaf. In this observation right here, the 1 is the leaf. In this observation, the 0 is the leaf. And in this observation, the 5 is the leaf, because the last digit in the number is the leaf. In this case, it's all in the ones place where that last digit resides. But maybe you can imagine a different example where this were 5.3 and this were 6.1 and 6.9. Then that decimal place would be your leaf. Whatever is the rightmost digit in your number is what's called the leaf. And all other digits are the stem. So in this case, the stem is the 4. The stem is the 3. The stem is the 1 here. And you're like, oh, there is no stem over here, right? If there's nothing, you can just think about it as 0. Think about this number as 0, 5. The stem is the 0, the leaf is the 5. In this case, the stem is only one digit, but maybe you can imagine an example where I had the number 125 also in here. The last digit is the leaf, so the leaf is the 5, and the 12 becomes the stem. So the stem does not have to be only one digit long, although in this example it'll just be one digit. Leaf, the last digit, stem, all remaining digits. What you do when you make a stem and leaf plot is you look for first your smallest stem and then your largest stem. So my smallest stem is a 0 that coincides with all these observations. My largest stem is the 4. What you want to do is write all of your stems from the smallest one to the largest one in increasing order vertically. So it looks like this. 0, 1, 2, 3, 4. 0 was the smallest stem. 4 was the largest stem. If I had an observation like 125, which I don't, but pretend I had that observation, then the stem is 12. You might think that I just put a 12 right here, but I don't. You list all of the possibilities from your smallest to your largest. So if I had that 12, I would write a 5, a 6, a 7, an 8, a 9, a 10, 11. I'll show you. I would write all of these until I got to that 12. And my plot would look more like this. So all of your stems from your smallest one to your largest one, even if those coincide with stems that don't even appear in your data set, is how you start making your stem and leaf plot. And then what you do, now that you have all your stems, is you add your leaves. So this observation had the implied 0 as the stem and its leaf is a 5. So what that means is next to the 0 right here, I want an added 5. Then my next observation, I got a 6, and then another 6, and a 7, and an 8. So the way I'm going to depict those is with the 6, another 6, a 7, and an 8. Note I'm putting all of these on the 0 row because all of these observations correspond with the stem of 0. And you come over here in our next couple observations, 10, 11, 12, 14. So those are going to go down on this row. All right, the leaf for the observation of 10 is just a 0, so I put the 0 here. This represents the observation of 10. This 1 represents the observation of 11. You can think about it like this 1 and this 1 makes 11. There's my 12. This 1 and this 2 makes a 12. Here's my 14. This 1 and this 4 makes my 14. Hopefully I'm remembering these right. Yeah. Then I got a 16 and an 18. 16, 18. I'm only writing the last digit because I'm only writing the leaf, and I have to make sure I put it on the row that corresponds with the appropriate stem. So far, so good. I only got 3 observations left. I have a 25, a 38, and a 49. So what I'm going to do is on this row, I'll put a 5. There's my 25. Here's my 8, 38. And here's my 9, 49. Here's my stem and leaf plot. Again, if I had an observation like, 73, 5, 6, 7, and then a 3, it's totally fine for you to end up, if I had a 73, it would look like this. Totally fine for you to have rows that don't have any leaves at all. You want to leave them blank. That symbolizes that there's no observations that have a stem of 5. I didn't have a 73, so my stems wouldn't have gone down to 7. They stop at 4. My stem and leaf plot looks like this. Couple comments on stem and leaf plots. In this case, the leaves were all the ones place, right? The leaf was this 4, the leaf was this 8. However, if I had decimals, if this were 0.5 and 0.6 and 0.6, the leaves would have been the exact same. So it would have looked just like this. I guess what I'm saying is, if all you have is this, you don't know if this 5 represents a 25 or maybe a 2.5 or maybe 0.25, right? You have no idea. If all you have is this stem and leaf plot, you don't know what your data looks like. So typically what people do is they include a legend. And the legend, you just pick any observation you want. It doesn't matter which one. I don't know, 2, 5. Just pick one of these arbitrarily, it doesn't matter, and say, that means 25 non-words, right? That's what I was tracking in this example. You include this legend just to describe one of the observations. Because once I give the reader this information, they know that this wasn't a 2.5, it was a 25. So you add this, sometimes it's in a box, sometimes it's down a little bit off to the side with an asterisk, whatever. That's a stem and leaf plot. And that's how you create one. Can't make them on these calculators, at least as far as I know, so that's one less thing that you have to learn. It's how to make them on a calculator. Just got to be able to make them by hand. Or I think what ends up happening more common than that is rather than make them by hand, if I gave you this right here, could you put all this data into a list? If I gave you this stem and leaf plot and asked you to find the standard deviation, would you be able to read this and understand what observations were given to you? Because that's really the goal of these guys. One more comment on a stem and leaf plot. If you take this stem and leaf plot, let's see, there's probably a way I can even do this. Rotate, let's see. If you take your stem and leaf plot and you kind of rotate it, you rotate it 90 degrees to the right, what you kind of get is something that kind of sort of looks like a histogram, right? If you remember the histogram that we did with this data, the shape that it had, it looked just like this. You can kind of think of a stem and leaf plot as sort of like a poor man's histogram, more or less. It's not as flexible as a histogram. It's a histogram where the bins are forced to be a given size. You don't have the freedom to, I want to count from 5 to 15 in my first bin, right? They're kind of locked in based on what your stems are. But it gives you a histogram. It's a histogram that's not too flexible. Just want to make that comment that sometimes stem and leaf plots are quicker to make than histograms. And so if you just want to have a kind of basic idea of the shape of the data, you can sort of get a basic idea of what your histogram would look like by making a stem and leaf plot. That's all I got.